Hi, I'm Andrew, and this is part 11 in my Advent of Code series, where every day I'm attempting to solve a new code challenge. The previous videos are on a playlist on my channel called Advent of Code 2022, and any day if I'm able to solve a challenge, the code that I write, I'll upload to a public repository. The link for that is in the description of the video. So let's get started for day 11. We have monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with our missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, which is our puzzle input, on the items that each monkey currently has, how worried I am about the items, and how the monkey makes decisions based on my worry level. So for an example, we have a list of monkeys, and we have starting items. There's an operation and a test. Okay, so each monkey has several attributes. Starting items lists your worry level for each item the monkey is currently holding in the order they will be inspected. So that's this. It looks like they're just numbers. Operation shows how your worry level changes as that monkey inspects an item. So operation new equals old times old. New equals old plus 6. Okay, so seems like there's some dynamic calculations that we'll need to do for each monkey has a different type. Okay, so an operation like new equals old times 5 means that your worry level after the monkey inspected the item is 5 times higher. Okay, so yeah, so for the items, this is their worry level, and it looks like after a monkey inspects the item, the worry level would change according to these rules. Test shows how the monkey uses your worry level to decide where to throw an item next. If true, okay, so we have a test, and that's if the item is divisible by 17. It looks like all of these are divisible. So for the test, we need to check if it's evenly divisible by an item. If it is, then the monkey will throw it to a different monkey. So, okay. So for each test, the monkey is going to throw the item. It just depends on the condition of which other monkey it will throw it to. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. So after each monkey inspects an item, okay, so we'll see what that means. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time and in the order listed. So monkey 0 goes first and throws all its items, then monkey 1 and so on. The process of each monkey taking a single turn is called a round. All right, when a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. Okay. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn, then its turn ends. Okay, so in the above example, this is the round, proceeds as follows. So the monkey takes an item with worry level of 79. It's multiplied by 19. So this happens anytime an item is inspected. The monkey gets bored of the item and the worry level is divided. So it takes 1500 divided by 3 would just get rounded down to 500, okay. The current worry level is not divisible by 23, so that would be 500. So this is where the condition is checked. This is the test. So then the item is thrown to monkey 3. Okay, and it looks like that just continues on. Monkey gets bored with the item. I don't think it said anything about that, but oh, this is where it was talking about, I think here. After each monkey inspects an item, our relief that the monkey's inspection didn't damage the item. So when the monkey gets bored, that must be what it's saying here. When the monkey gets bored, it didn't damage the item. Okay. So let's see. After round 1, the monkeys are holding these items. So each round, whatever items the monkeys are holding is probably going to change because they're tossing them between them. Monkeys 2 and 3 aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. So, okay, the process continues. So this is what it should look like at the end of each round. Chasing all the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope getting your stuff back. So count the total number of times each monkey inspects items over 20 rounds. So it would be monkey 0 and 3. Okay, so it doesn't seem to be based on how many items the monkey's carrying, but instead how many they've inspected. So if monkey 0 tosses an item to monkey 3, then when monkey 3 inspects it, if it sends it back to 1 of the other monkeys, then it would still count. Okay. In this example, the 2 most active monkey inspected items 101 times and 105 times. The level of the level of monkey business in this situation could be found by multiplying them together. So 101 times 105. So figure out which monkeys to chase by counting how many items they inspect over 20 rounds. All right, so we just have a fixed, it looks like a loop. We'll have to go through each of the monkeys, perform all of these operations 20 times, and then just count how many items each monkey inspected, and then just figure out the 2 highest and then multiply them together. So what is the level of monkey business after 20 rounds of stuff slinging simian shenanigans? Okay, there's a lot to unpack here. First off, what I'm noticing is this input is going to be probably tricky to parse, but that's what I'm going to start by trying to figure out. So let's get the puzzle input. Fortunately, there's only 7, but I don't think it matters. I mean, just doing 1 is going to be tricky. Let's put it into our code and get started. So looking at this, we'll just have to probably write something that goes in order here, and we'll want to make something to model these monkeys, and then probably have some of the behavior inside of there. So we'll want to go through, add monkeys, maybe have a list of monkeys, and then each monkey will have starting items. So yeah. Okay. I'm gonna start by creating the model for the monkeys and just kind of figure out what stuff it's gonna have in it, and then I'll have to find a way to map these to those models. So I'll make a class for monkeys, and each monkey is going to have a list of items. Okay. I think those could just be integers because we need to track the worry level, but the worry level is just this number. So anytime we have an operation, it's just going to modify that number. So we'll have a list of integers for items. We will have to have the operation that the monkey performs, because that's going to be different for each one. It's always going to assign the new item's value to something. It's always going to use the old value at least once, but here it uses the old value twice. It would be a lot easier to just hard code these values into a list of 8 monkeys, but I really want the parsing logic for my programs to work with any input, so we're just going to have to figure out how to build this out dynamically. Okay, so it's going to have, I'll probably have to make some sort of class to represent this, because we can have multiplication or addition. Yeah. Okay, so we're always going to have the old value. Then we're either going to have multiplication or addition, and then we will either have a new value or the old value again. Okay, so let's have inspection type or inspection operation even. I'm just going to make this an operation class, figure out how to do that. Operation. And there, okay, so what I might do is just have some subtypes of operation and then put a function for calculating or execute. We'll execute the function. And then we'll have a class for add and multiply. And these will extend from operation. What is here? Oh, we need to make operation open. Maybe an interface would work better here. We'll see. We'll see how it goes. Okay, so monkey can either have an add or a multiply. And I think I will make this an interface. Okay, and now there's no constructor, and we need to implement that. Okay, so we'll want to override execute for both of these. There we go. So when we're parsing, we'll need to just figure out how to represent this type, and then there will be a test. A test is a single item, and it will have 2 results. So we're going to need to, it's always going to be divisible. It looks like the test is always whether it's divisible. So we could probably just get away with storing the number that it has to be divisible by, and then the monkey if it's true, and the monkey if it's false. Okay, that's an easy enough class to make. We'll call it test, and we'll have, we'll just call it the value is an integer, and we'll say true monkey is another integer, because I think we'll have our monkeys in a list, so this could just be the index that we track. And false monkey. Okay. So we're going out and building these. We will just be able to create a class with this as the value by splitting, and then same thing here, just splitting these and taking the last item. It's always in the same order, right? If true, false. Okay. I think that will work for parsing. Yeah, I'll probably have to figure out more with the operation when we get to it, but for now, let's just start filling out what we can. For part list, I'm going to have or for part one, I'm going to have a list of monkeys, which will be a mutable list of monkey. It'll start out empty, and then we will take our input and kind of go through line by line. Yeah, there's probably going to be quite a bit of parsing logic. This would be a good chance. I think inside of monkey, we can just have um, a function to build it out. Oh, and I need to still add the test here. Test. There we go. So each monkey has a list of items, an inspection operation, and a test. Okay, and then we're going to have we'll need to make a companion object, and we'll make a function from, which takes I think for parsing these, what we'll do is just split out the group of lines for each monkey, and then we'll pass that in to the monkey builder, and then let that figure out the logic for these. So there's not too much going on in the part one. So we'll take it from a lines, which is a list of strings. And that's going to return a monkey. And then we'll need to do that here. So return a monkey. Yeah, I'll need to figure that out. So for here, let's say input. How would we split this out? We want to get the list of, we're going to need the indexes of whenever a new monkey configuration is started. So I think I can just do a indexed list, or for each indexed, and go through, and anytime we get to a monkey item, so like when we get here, we'd be an index of 7, and that's how we would know to take everything before here, and we'll just like sublist. Yeah, okay, so we'll make a variable like this and say, what would it be called? A monkey configuration. Say, we'll just call it config start. That'll be at 0 and config end. And this will be the range that we're going to split out for each monkey to pass into our builder. Okay, so input will go for each indexed. Okay, and well, let's see. Actually, I think we can, so here we can make a list of monkey configurations and say monkey configs, mutable list of, we'll start it out with a mutable list of strings. And what this will let us do is just go through this one time without doing these, without doing those ranges and sublisting. We'll just, if we get to a line like this, we'll add a new monkey to the list. Yeah, okay. So we could just start this out as empty, actually. So it'll be something like this. Okay. This is going to be interesting. So for each, I think we just do without indexing. Yeah, okay. And then what we'll do here is monkeys, we'll create this by taking monkey configs and then mapping. Here we're gonna have a list of configs, and we'll say we're gonna create a monkey from the config. Great. So let's name that here. All right. So let's do our iterator logic. If the line starts with monkey, we are going to add new config list. Else if it starts with, let's see, actually I don't think it matters at this point. The only thing that we care about for the configuration list to break these out is that we're adding each line to the last. So that's what we'll do. If it starts with monkey, then we're creating a new item in our list. Otherwise, we're just going to add this line to the last configuration item. Yeah, and we'll call this line. Okay. So what this will do is when we actually are down here creating the monkeys, we're just going to have that list of all these things, and we'll need to parse it out further. Yeah, but I think this is a good start. Let's just do that. Yeah, okay, so monkey configs, we're going to add a new empty list, empty mutable list of, yeah, there we go. So now the next step is going to be figuring out what to do with each of these lines. I want to stop this for a second and just debug kind of what this looks like. So I'm going to set a breakpoint and just check that monkey configs is doing what I want it to. All right, so we have a list of 8 monkey configs, which is what we would expect. Let's just see that they show kind of the right ranges. So here we've got a list of starting items, and it ends with this case. Actually, it ends with this empty line. So then for our second monkey, it should be the same. Yep. Cool. Okay. And I think I could probably also just cut out a blank line because we don't need to do anything there. So then when we're creating our monkey object, each of these lines will be important. So I'm going to do that and then move on. Else if the line is not blank. Cool. So then let's get to the rest of our logic of creating these. So the first item in the list is going to be starting items. So what we could do is just split out from this semicolon, and that's kind of where our list will start. And then we will split out by commas, and that will give us each item separately, and we'll just trim the space and convert these to integers. So let's do that. So we'll say starting items is config first. Oh, yeah, this could get Well, no, they're all the same size. So I can use the index for these. So this will always be the first, second, third, fourth, and fifth. Okay. Great. So starting items, we'll use numbered index uh, accessors here. So the starting items is going to be config 0, and we're going to split by a semicolon. And we will take the second part of that. That'll be here. And we're going to split that by comma. Split by commas. Split. Is there something like this? No. Okay, so split map will trim. Maybe we don't need to. Maybe even if there's a space, it can convert it to an integer. To int. Let's try that. Yeah, we'll try that. Let's see how it goes. So then for the second part, operation. So this is where we're going to create that operation. And again, I think we can just ignore everything over here because that's always going to be the same, right? Yep, each of these has the same. The only difference is going to be if it's multiplying or adding, and then whether this is a number or old. Okay. Yeah, I'm not sure how to represent this. I think I'm just going to add another, I'm going to add another operation here for squaring. That'll kind of simplify what we do. Class square. And we'll make that extend operation. Okay. Cool. So that way, if well, the first thing we'll check is if it ends with old. If it does, then it's squaring because there's no plus old. It's just times, yep. Okay. So let's do that. Operation equals config the second line. We can split by the equals, which will just give us this end part. Split equals. We'll do a let here because we're going to transform this kind of depending on things. We'll say if the end of the line is old, I think we can use that logic. Oh, we want to take the second part of this split. And that'll just give us a string like this. Okay. If it ends with old, we can return square like this. Okay. Else okay, so now we're either going to be multiplying or dividing. So we'll say if it contains a plus, adding, else, I think we can just assume that we are multiplying. And in order to create those, we should have a value to hold how much we're adding or multiplying by. So we'll make this and do the same thing here. For squaring, it doesn't matter because it's always just going to take whatever the current old value is of the item. Okay, so we will say add, and when we create this, we need to pass the value, and we can get the value by splitting If it's adding, we can split by the plus and take the last item. Okay. Value is going to be, I don't like using it for multi-line, so I'm going to name this. What would this portion be? Can't use operation because I'm always already taking this. We'll just call it our string. Like that. Okay, so the value is taking the string, splitting by, we already know it, we're adding, so we can split by the plus. We will take the second part of that, and we will call that to an int. So then we will return the value, creating an add with the value. And we'll do the same thing here, but with multiplying, we will want to check if this is a star, I think it uses. Yeah, a star. And we'll do the same thing, we'll just make a multiply object. Okay. So that gets us the starting index, or the starting items in the operation. So we'll put those in here, starting items in the operation, and now we just need to pass in the test. Okay, so that's going to be the next 3 lines. So what we can do for each of these is just take, because like the rules are always the same. It's divisible by a number, throw to monkey of index, throw to monkey of index. So for these next 3 lines, we'll just take the last value, so we can split by spaces. That's what I'll do. Okay, so our I'm gonna make a rule, or I'm sorry, it's a test. Test is gonna be making a test like this, and I think when we create it, I can just have each of these default to 0, and then I'm gonna fill them in after each line, just for simplicity's sake. So I'll make these all variables. And when I do this, I can just start with a empty test, and then I can take the next 3 lines, which is going to be, it's going to be, it's going to be the config, it's going to be 2, 3, and 4. Okay, and we're going to say, also, actually we'll split it by spaces and take the last item. Okay, so we'll do that for each one. To integer. Okay, we could do that and just put it inside of different parts of the test. So also test test value is going to be this, and then false monkey will be this, and true monkey, or actually I think it's true first. Yeah, true is first, then false. Okay, so true monkey and false monkey. Cool. Yeah, I think that'll work. So then the point of all this is we will be able to then just we'll just be able to take our monkey objects and kind of perform all these rules in a list. So I'm going to debug and just check that monkeys is getting built correctly and that all of this logic worked. Okay, and we got an error. That's because there's a space. Okay, so anytime we're doing toInt, we're just going to trim it first. I should have known better, but that's okay. So we got toInt. We will trim it each of these points like this. Okay, now I think we can run it. And there we go. So we got our breakpoint. We have 8 monkeys, and that's good. There was 8 configurations. Inside of each monkey, here's the items they start with. Okay, the inspection operation for the first one is multiply. So it takes the old times the 5. Multiply, the value is, how can I check this? Multiply, the value is 5, okay. Divisible, the test, the value is 11, that makes sense. The true monkey should be 3, false monkey is 4. Cool, yeah, I think this is everything we need. Yeah, monkey 5 should only have 1 item, 50. All right, so that's kind of the first big hurdle here. Now we should be able to just iterate over these, what was it? I think 20 rounds. And then we'll just check our stuff at the end. Oh, and the monkeys will need to keep track of how many inspections they have. So I'll make another, I'll make a private variable in here called inspection count. It's gonna start at 0. Yeah, so for this part, we're actually gonna have to add some functions for monkey. In order for it to, let's see, we'll have a function for throwing an item and for inspecting. So let's first start with inspect item. And we're going to call these outside in our loop here. So we'll say monkeys, or so we're going to repeat 20 times, repeat 20. And then monkeys, we're going to go for each. And then for each monkey, it's going to what? Just inspect items. So what does it say? So the monkey takes turns inspecting an items. On a single monkey's turn, it inspects and throws all of the items. So we will just have to have a function maybe on a monkey for take turn. Yeah, sure, we'll call it that. Oh, monkeys, we're gonna do that on the monkey itself. Monkey, like this. So now the monkey will take its turn. We'll create a function in here. And what this will do is it'll say items for each inspect. I'm not sure what we're going to do for that. So we'll just stub it out for now. So when we inspect an item, we'll also need to throw an item. Throw an item. Okay. So when we throw an item, it's going to take it out of our list and add it to the end of another monkey's list. So each monkey we should have this be, oh, it should be a value, but it should be mutable so that we can remove and add items. I think what would be cool is if we could pass the other monkeys to each monkey. So yeah, okay. How would we do that? I think we can, when we take a turn, we could just pass it all the other monkeys in the list. Yeah, let's do that. Take turn, other, we'll say monkeys. Yeah. So now take turn, when we take a turn for a monkey, we get the list of all the other monkeys. And then we will take our items for each. We will inspect the item and we will throw the item. those will do different things. So when we, and when we inspect the item, the inspection count will be incremented. That's important because we'll check this at the end. In fact, maybe it shouldn't be private. So when we throw an item, we're going to throw it to another monkey. So we will say other is going to be a monkey. Yeah. Okay. So let's kind of take this one step at a time. I think I'm kind of adding a lot here. Yeah, when we throw an item, so let's figure this out. When the turn starts, this is what happens. Or when the round starts, the first monkey takes their turn. That's already handled because we're doing monkey for each. Then we're going to go through each item. So this is the logic we need to sort out. He inspects the item with a worry level of 79. So the worry level needs to get multiplied, and we already know that. It needs to get added or multiplied, so by inspecting, we're going to have another function for increase worry value. And that will take, will it take an item? It can't take an integer because we can't modify an integer, so we need to know. Well, anytime we're doing this, it's always going to be on the first item, so we don't need to pass around the index. We will just always take the first item in the list. So inspecting an item will increase the worry value. And we are either going to multiply or add. So for increasing the worry value, we will say if inspection, we'll take the inspection operation. Inspection operation also if it, so right now it only has the execute function. I think it should have operation, okay. If it's add, that's what we'll do. We'll just check if it's each type. If it is add, like this, I think that'll work. If it is add, else if it is multiply, it is square. Okay, so we'll do something else each time, and what that's going to do is if it's squaring, for example, we'll take the items first is going to equal, we can't do that. We need to do our use indexes. So items 0 is going to equal items 0 squared. Is that? I'm sure there's a math function for that, but I'll just multiply it out here. It'll always be times itself, the old value. And I'll copy this up to multiply because instead of doing it by itself, it's going to take it value. Okay, and here, instead of multiplying, it's going to add. Yeah, I think that's good. This is saying I could change it to a when. I'm not sure that's much better, but sure. Let's move these to single lines. I think we can do. No, it's always going to break it out. Okay, that is fine. I'm going to make these private. Yep, like this. All right, so the first thing, it inspects an item, it increases the worry level. And the monkey gets bored with the item, then the worry level is divided. It's always divided by 3. So, okay, we'll say we'll reduce worry level, and that's going to take it's going to do the same thing. Um, First item will be divided by 3, and I think we need to round it down as well. Worry level is divided by 3. Okay. I think it gets handled in Kotlin. When we divide an item, if we take like 10 divided by 3, I think it's going to round it either up or down. So I'll want to figure that out. Is there a divide? Divide? Floor divide? What does that do? Maybe that's what I'm looking for. Floor divide. Yes, okay, divides this value by the other value, flooring the result to an integer that is closer. Okay, I think that'll work for me. Floor divide 3. Yeah, let's try that. So we increase the worry value and then we reduce the worry value. Yeah, I'm gonna rename this. Okay, and that always happens, right? The worry level is added or multiplied and then it's divided. The current worry level is not divisible by 23, so that's what we do here, is we check, we run our test. So we run our test and then we either throw it to one or the other. Okay. We can do that with throw the item. We can put that in here. So inspect the item, and then we are always going to throw the item, but we don't know which monkey to throw it to yet. Okay. So we'll need to test item. We'll make a function for that. On test item. And we will say, we already know our test. So test, what was it? Test value. So we want to check if item's 0, we can use the modulo again, but we're going to use it by our test value is equal to 0. This means that it's evenly divisible by something. Then we will do one thing, otherwise we'll do another. So here we will throw the item. And this is just going to be the monkey's index. What do we have here? So when we take a turn, I think we can get rid of that. So or no, we'll move test item up here. Test item and throw item. So this will return an index. Testing item will return an integer that'll tell us which monkey. So let's do that. And we'll just return the test true monkey. Otherwise, the false monkey. Like this. Yeah. And we can just lift the return out of there. Cool. So when we throw the item, we are going to throw it to items, or no, monkeys. We're going to get the index of test item. Okay. We'll assign a value here. So val monkey to throw to is test item, and that's going to be our index like this. Okay. I think so far so good. And then throw other item is just going to add this to the other monkeys in inventory. So other, we can say items is going to add our items, the first item, and yeah, so from there we will also want to remove it from our own inventory. So items remove first. Cool. I think that kind of makes sense. We still have, is there an error somewhere? Yes, down here, what's happening? When we create an item, we need a mutable list, but we have a list. So starting items will just be this to mutable list. There we go. Okay, I think we can run it. I'm going to run it with the sample sample data here, just so I can follow along and see that it's kind of working like I expect. Okay, so I have a breakpoint set up here. This will show me what things look like at the end of 20 rounds. And we got an error and concurrent modification exception. So that's when I'm trying to modify a list while I'm also reading it. Where is that happening from? Here, take turn. It's happening inside take turn. Let's check that out. So items, while I'm iterating inside of it, I can't throw the item. Okay. Yeah, that's a problem then. We will need to do something else. I think just for simplicity's sake, I'm gonna create a new list from items because the rest of this is all working so well. I don't want to introduce more than I need to. So we're going to make a copy of the list that we'll go through. That shouldn't change anything. Well, actually it will, because if I have a copy and I'm modifying them with their worry level, yeah. Okay. Then I might just need to do a for each indexed like this. Okay. So then when I inspect the item and I do any of these things, I'm going to need to just pass the index, throw item. Again, there we go. And we'll add the parameter. Okay. So here, instead of accessing 0, we're always just going to access index. Same here. We're going to check this and inspect item. The same thing for the index. We're going to do it to whichever item we have. We'll need to pass it into these. So a little extra work here, but overall I think it's important to do. Yeah, I'm going to copy this over since it's the same for each line. Yeah, okay, like this. Oh, here we need to do the index as well. Okay. I think that might be the only thing left. And then what do I need to do? I need to remove the first item. So this will still be a problem because I'm removing it while I'm iterating through it. So now after this is done, I will just take items and clear it. That should do the trick. Okay, and there we go. So in our example, there's only 4 monkeys. Let's see what they look like at the end. What should they look like at the end? I guess I can check their inspected item count. I will, oh, we should just be able to look right in it. So if we come here, inspected count 101, 95, 7, and 105. 101, 95, and 7, and 105. Cool. Looks like that's correct. So I'm going to put the real challenge input back in here, and I'm going to return, I'm going to return the logic here. So we need to take monkeys, sorted by the inspection count, and that's going to be descending, so that we start with the largest values. We will take the first two and we'll sum. No, I think we need to multiply them. Yeah. What is wrong here? Two. Well, the list. Yeah, okay, so we need to take the first times the second. Like that. Found a unit. I'm not sure why there's a problem with this. Right, okay. It first inspection count. Okay. Let's see. I think I can combine some of this sooner. So sorted. First, I'll map them to their inspection count. It's inspection count. Like that. Then when I go sorted by descending, I don't even need to pass it an argument like this. We could just sort it by descending. Sorted descending. There we go. And now I can take those two items and multiply them together. First times the second. Okay. Yeah, let me just do that again here to make sure that it returns the right number. It was 10,605. That's what I should get here, 10,605. So let's run it on the real data. And that should be our result. We got 120,754. And that is not the right number. If you're stuck, make sure you're using the full input data. The only thing that I can think of that I did a little differently was flooring the items when I divide them. So I'm just going to run through that and see if anything weird is going on there. That happens when we're reducing the worry value. If for some reason this isn't working correctly, so I'm going to print out something here just for some debugging. I'm going to print out the items. Here, I'll do something like this. I just want to see if this is ever different than what the regular result would be, or maybe if it's not catching some items. So I'm going to print out items, the result of just dividing by 3 and seeing what the remainder is. And I'm going to also see what the result of this operation is. Maybe that'll give some insights. Okay. Looks like they're all about the same, which is interesting. Also, I didn't think that the regular division would trim the any remainders off, but it looks like it does. Oh, there's some negative values. Um, oh, and some of these are different, but just the negative ones maybe. Let me take a look. Oh, you know what? Floor divide. This is always going to return the result that is closer to negative infinity. So in this case, the floor divide is rounding. Oh, I wonder if that matters. Because would it want this to be 121 instead of 122 if it's somewhere in the middle? Technically, 122 is rounding down. It's lower, but I'm going to check that. Going to check that. How about I just try this with, yeah, without using the floor divide, just a regular operation here. That'd be funny. I tried to use something better. Let me run this. Do I get a different number? I do. 121,103. Let me try that. And that is not right either. Okay. I wonder what could be going on. I just checked those negative values to make sure they were rounding right. And wait a second. Negative values. Why are there negative values? Because we are only ever adding and multiplying them. So let me undo this. We shouldn't ever have negative values unless they are getting so large. Let me log these and see. Increase the worry value. Val start is the current value of it. Yeah, I'm wondering if they're overflowing the integer. Because if we're multiplying, I guess they could get pretty huge. The index. Okay, I'm going to print a line here. Actually, yeah, I need to filter it out. So if end is less than 0, then I'm going to print what happened here. This start turned into end. Okay, run this again, see what we get. Yeah, okay. Oh, there it is. That's the first time. Okay, so we had a value here, 80. Yeah, okay, so when this gets multiplied out, it gets too large. Okay. What do I need to do? Do I need to make this a different type? These need to be longs. Oh, I wonder if that'll mess anything else up. Okay, well, I think everything else down here will still work. I can't use an equality. Oh, I can just convert that to a long. Okay, monkeys. Yeah, starting items. Too long, maybe? Okay. Um, yeah. Well, these don't need to be, because this is where I'm parsing, so these can still stay as this. Well, no, I guess the type has to be long. So yeah, that's fine. Even though these are integers to start, they can end up being long. Okay, I'll run it again and see what we get. Okay, now there was never a negative value. This is 120,756. Is that different than I was getting before? I don't remember. Okay, we'll try it. Oh, okay, there we go. That was the right answer. So that was, yeah, that was tricky. I'm glad I caught that. Okay, I'm gonna move on to part two now and see what we got. You're worried you might not ever get your items back. So worried, in fact, your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. That relief was all that was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. So with these new rules, you can still figure out the monkey business after 10,000 rounds, using the same example as above. Okay. So after looking at part two for quite some time, I'm going to have to concede and say that I won't be able to solve this for today. I'll just take my 1 star that I got from part one and check back in tomorrow for the new challenge. Thanks for watching.